Hi everyone, welcome to the first class of ESP32 Pixel. I am Collier. In this class, I will demonstrate how to install Arduino IDE and how to configure the compilation environment of ESP32 Pixel. First, we open the browser. Then we search for Arduino IDE. Next, open the first page of the search results. After coming in, you can see that it is currently on the software page of the Arduino website. You don't need to worry about not finding this web page. I will include it in the wiki tutorial with images and text. And you can find the entrance to the wiki on the Eleunit website. Now we return to the Arduino page, and we can see that the latest IDE version is 2.3.4. When you scroll down, you will see a more classic version, January 8th, 19. Because this version has good stability and compatibility, some people still like to use this version. But I still recommend everyone to use a newer version like me because this new version is quite user-friendly, and I think it is also suitable for beginners to get started. Next, here on the right, there are different installation programs for different systems. There are 3 different systems: Windows, Linux, and Mac OS. You can choose the corresponding installation program based on the system you're using. In the installation program for Windows, there are also 3 types. The first type is the manual installation program. The second one, MSI Installer, is an automatic installation program. This means that after we download this installation program, we just need to run it, and it will automatically install Arduino IDE without any manual operations. And this compressed version means that it is portable, but we usually don't use it. So I still recommend everyone, like me, to download the MSI installer to install Arduino IDE. We click on it to enter the download page. Then, you can contribute or simply click, just download. After downloading, we click on it and run the installation program. After running, we don't need any operations, it will automatically install. And the installation speed is very fast. It will take about 1 minute. When you see the installation program disappear and see an Arduino IDE icon on the desktop, it means that the installation is complete. Next, we run it. If you are running it for the first time like me, the Arduino IDE will automatically install the development package for the Arduino board and some necessary libraries after running. Please do not interrupt it. Here's the progress bar for the installation. When it disappears and the printing information stops here, it means the installation has been completed. And during the installation process, it prompts to install certain drivers, but my screen recording software cannot capture this part of the screen. You just need to choose to agree to the installation when prompted. This is because we also need these drivers when using the ESP32 Pixel board. Now the installation should be complete. Then, we click on this icon to open the board manager, and we can see that the Arduino board package has been installed in the IDE. However, we also want to install the development package for the ESP32 board. But what we need is not this one, we need the development package provided by Espressif Systems. But the Arduino IDE doesn't know where to download these development packages, so we click on File, then click on Preference, and then we find Additional Boards Manager URLs. Next to it, there is a button. Click on it. It's blank by default. Then we open the browser and search for Arduino ESP32 package. Then we open this page. This link will also be placed in the Wikipedia tutorial. Of course, that includes this link. We need to copy it to the blank field above. Copy, paste. Now we have told the IDE to fetch the development board information for various versions of ESP32 from the link provided by this JSON file. Then, click OK. At this time, the IDE will automatically download this JSON file to the local machine. Once the progress bar disappears, it means the download is complete. Then, click here again to open the board's manager. If you are using an older version of the IDE, it does not have this toolbar. You can click on Tools, then find Board, and clicking here will also open the board's manager. Then, fill in ESP32 here and search. Now we can find the ESP32 development kit provided by Espressif Systems. Then, we can find the latest board version 3.1.0 and click Install. Since the installation process takes a long time, I will skip this part of the screen. Okay, now it is already installed, and you can see here that a lot of information is printed, including the version of the installation package and certain required libraries. Then, we can see here that the ESP32 development board version 3.1.0 has been installed. Then, click here again to close the board's manager. Next, we can start developing the board powered by ESP32 chip. Once you have written the code and configured the compilation environment, you can upload the code to the board and drive the board to work. But how to confirm it? You can click on Tools again, and when moving to the Boards option, you will see that the ESP32 option has appeared. This indicates that the current development environment of Arduino IDE supports ESP32, including all boards powered by ESP32. And our ESP32 Pixel uses the ESP32 S3 chip, so we need to set the board option to ESP32 dev module before compiling. Okay, next, I will demonstrate how to use the ESP32 Pixel board to send a message, "Hello, Eleunit," to my computer through the serial port. First, I will initialize the serial port for my board in the setup function. When initializing the serial port, we need to fill in an important parameter, which is the baud rate. I will set it to 1150-200. After completing this step, we can write the greeting code in the loop function. However, you may wonder why we need to write the code to initialize the serial port in the setup function and the greeting code in the loop function. Because the code in the setup function is only executed once, that means when the Pixel board is powered on, it will first execute all the code in the setup function, and this part of the code will only be executed once. All the functions in the loop function will continuously execute after the setup function is completed. So now I need to use the print function with the serial port here to print the message "Hello Eleunit," or use the println function. ln represents automatically adding a carriage return and a new line after printing the message. If you remove it, the serial printing message will have this effect. If I only print "hello," it will immediately print "hello" afterwards. But if we add ln, it will have this effect. In order to make the received information look neater, I will use the println function. Also, please note that the text message to print should be enclosed in double quotation marks. "Hello Eleunit." However, if we don't add a delay, the printing speed will be very fast, and we won't be able to see the printed information clearly. So, it is necessary to add a delay here. This delay function needs to be filled with a parameter, and we fill in 1000, representing a delay of 1000 milliseconds. Now we have completed the code writing. Next, we just need to upload the code to the board. However, before uploading, we must first configure the compiling environment. Click on Tools, find Boards, and select ESP32 S3 dev module as the corresponding chip for the Pixel board. Next is the port. I haven't connected the Pixel board to the computer yet. The device with the port number COM1 is my wireless network card. Now, I take out the board and a USB Type-C cable, connect the board to the computer, and turn on the power switch of the board. Returning to the Arduino IDE, check the ports, and now there is an additional COM4 port. This is the port number assigned to the Pixel board after connecting it to the computer. On your computer, it may be COM6, COM3, or others, all assigned by the computer. After confirming the port, let's look at the next item, which is PSRAM. Depending on the chip mounted on the Pixel board, we need to select the OPI PSRAM option. Then, let's look at the last item, partition scheme. Since the memory used by the code in this lesson is relatively small, we can choose the default option. However, in the subsequent lessons, we will use LVGL, which will occupy more memory, so we need to select the Huge App option. Overall, there are 4 things that need to be configured. The first is the board, the second is the port, the third is OPI PSRAM, and the fourth is the partition scheme. After configuring the build environment, you can upload the code. Find the icon with the arrow and click on it to upload the code. Because the code for this lesson is relatively simple, the upload speed will be faster, and the Pixel board does not need to manually enter download mode, it will automatically write. Now you can see that the code has been successfully uploaded from the output box. At this point, we click here to open the serial monitor. You will find that the text received by the computer is not "Hello, Eleunit." That is because the baud rate of the serial monitor is currently 9600, which is inconsistent with the baud rate of the Pixel board, resulting in garbled characters. Let's change it. Okay, now you will see the information received from the serial port, which is exactly what we expected, printed every second. Additionally, there is another setting that I consider important. Before uploading the code, the IDE compiles it, but we didn't see this process in the output box just now, only the upload code log. The compilation log helps us understand if the libraries used in the code are correct and helps us with debugging, so we need to make it print out. Click on File, open Preferences, find this option, and check both of these two options. Now, when we upload the code, you will see the log information generated during the compilation process in the output box. Okay, that's it for this class. If you have any questions, you can visit our website and open the wiki, where there will be detailed tutorials with graphics. Alternatively, you can visit our forum and post a thread about the issues you have encountered. I will reply to your message as soon as I see it. Alright, if you find this video helpful, please don't forget to give me a thumbs up. Thank you for watching.